Good morning, everyone. We have one virtual speaker joining us this morning, so we're just trying to make sure that he's going to be able to join. So just hold tight for another minute or two, and then we'll get started shortly.
Hello, can you hear me? Can you hear me? I cannot hear you.
Wonderful. Good morning, everyone. Thank you so much for joining us for our side event, the Global Stocktake Joint Action for the Climate and Biodiversity Crises. My name is Kasprzyk. I'm Senior Manager for Climate Policy at Conservation International, and I'm joined today by a distinguished panel of some guests who are going to talk to us today about the Global Stocktake and climate and biodiversity action. And this side event is jointly hosted by Conservation International, BirdLife International, and NABU. So just a brief overview of the agenda. I'm going to provide some brief remarks, introductory remarks to set the stage for kind of the diversity of topics that we'll be covering today, and set the stage around the Global Stocktake and how it can be a springboard for action for climate and biodiversity action. Then we'll have a few, our speakers will present. We have Giacomo Grassi joining us virtually, Amy Fraenkel, Araceli de Carla Sebastián, and Carla Freund. And then we'll do a quick wrap-up about what this means for the Global Stocktake and our recommendations for the final phase of the Global Stocktake. We'll have a moderated discussion, and then we'll hopefully have some time for questions and answer by the end. So just to get started, the Global Stocktake and the overview. This is a process that has been ongoing now for about a year and a half. It's an integral part of the Paris Agreement ratchet mechanism, the ambition mechanism, and this is the very first Global Stocktake that we're just reaching the very end of the technical assessment phase right now. And the goal is, it's quite simple, but it's kind of a complicated process, and I think it can be a little confusing to some in terms of the different phases. So the Global Stocktake actually got started at COP26 in Glasgow with what was called the information collection and preparation phase. And this kind of kicked off this about a year and a half of getting inputs from a variety of sources. So parties, the UNFCCC, non-party stakeholders, on a variety of different questions about how are we doing in terms of meeting the goals of the Paris Agreement. And this has fed into what's called the technical assessment phase, which, as I mentioned, just ended yesterday at the closing plenary. And this consisted of 3 technical dialogues and to consider these inputs. The first one last year started with a focus on what, kind of this idea of, how are we doing, what has been progress to date, what are the gaps. Then at COP27, the dialogues focused a little bit more on the how, right? How do we close the gaps? How do we move forward? And then the technical dialogues that took place last week were focusing a little bit more on the so what questions, right? So how do we move forward? And what are the implications of the findings for the Global Stocktake for the next round of NDCs and collective progress? And then now that the technical assessment is done, we'll be moving into what's called the consideration of outputs phase. And this is when parties and non-party stakeholders and political leaders will start to discuss the implications of the findings of the technical assessment. And then at COP28, there will be high-level events, which will be chaired by what's called the high-level committee to convene political leaders around the messages coming out of the stocktake, which will then inform the final outcomes. So for us, we're thinking about, what do we need to make the Global Stocktake an impactful process, right? There's a lot of talk, a lot of information, kind of an overwhelming amount of information. And so how do you take all of this huge body of information and get something out of it at the end that will make a difference in terms of the next round of NDCs and collective progress? And so some things that we're thinking about that are really important moving forward is really high-level buy-in, especially from governments, but also from the private sector, civil society, and Indigenous peoples and local communities around what the outcomes are and what's needed moving forward. And moving into this last political phase, as folks are calling it, it's a process, right? It'll culminate at COP28 with these high-level events, but that can't be, right? We can't not have anything on the Global Stocktake between now and COP28, right? There's the next few months will be really a key moment to galvanize this political buy-in. And so this will require kind of like a pre-Paris moment when we'll be looking for high-level commitments from governments, from the private sector around commitments to action. And the Secretary General's Climate Action Summit in September should be a really key moment for this, to signal that countries are really willing to step up and put new commitments on the table. And a really key part of this will be not only the Climate Ambition Summit, but regional climate weeks and other pre-COP events that will be convened by different governments, civil society, and different actors. And this will be important to spotlight different outcomes. A really key part of this as well is inclusivity of non-party stakeholders, right? Even though the final outcomes will be, taken by parties, if they're only, if there's only buy-in from governments on these, and there hasn't been, the proper inclusivity of different actors, then there won't be total buy-in on the outcomes at the end of the process. And then, as I mentioned, right, these high-level committee events during COP28 will be really important to galvanize that support from world leaders. So not only do we need the buy-in, but the outcomes themselves need to be specific enough to drive action. And this can be kind of a difficult needle to thread in the Paris era, because we tend to get negotiated outcomes that are very high level, and so we're trying to use the Global Stocktakes process to get to a little bit more specifics about where do we need to go within that CMA decision. And we would recommend that parties focus on no-regret solutions that we know are needed across all countries to guide national action and international cooperation. And this idea that guidance would be voluntary, right? That guidance from the global stocktake can then be considered in a nationally determined manner to select the no-regret solutions that are most appropriate for each country. Another important element are technical outputs, so taking the very rich detail of the technical inputs from the assessment and the information collection, and putting them into a format that are useful for national governments moving forward. And not losing all of that information that we've collected over the past year and a half in terms of making it useful for action moving forward. And then it's also really important, right, because we have this stocktake process, to highlight that there's still knowledge that we need to make climate action more effective, and making it clear what some of those gaps are so that we can continue to address them over the next few years, so that hopefully by the next global stocktake we'll have that information available to inform the next round of commitments. And then finally, I would say that we need financing for the UNFCCC mechanisms themselves to support implementation, right? The Paris Agreement and its implementation have created a lot of new bodies and a lot of new avenues for countries to implement Paris, but they're not actually well funded. And so getting getting the financing to make the UNFCCC mechanisms, the financing mechanisms, really most effective can help make sure that the decisions coming out of the global stocktake can be fully implemented. And then thinking a little bit more about the climate and biodiversity linkages, what do we see are, they're kind of still missing, right? We're getting some there have been key messages that have come out from the technical assessment. But in terms of the climate biodiversity and climate nature linkages, there's still a few things that we would like to see moving forward. And this is really language that pulls to the top, right? The urgency of implementing nature-based solutions and transformations in agriculture in terms of pre-2030 action, right? This first global stocktake is really the time when these actions need to be taking place. Also, highlighting nature-based solutions as no regrets, win-win solutions for mitigation, adaptation, biodiversity, and people, right? And not only that, but that nature-based solutions, with the UNEA decision, we have some additional implementation frameworks, that we have a clear approach for implementation around nature-based solutions that make sure that the implementation really is galvanizing on the synergies rather than some of the trade-offs. One of the other elements is the need for cross-sectoral integrated action for both the energy and land use transformations. And this is something we'll be talking about more today. This idea that the energy and land use transformations are they're both land-based, right? We're talking about needing land for both things, and making sure that we're managing the trade-offs around any kind of place-based action and biodiversity. And then, as I mentioned previously, the need to close some key gaps. There's especially large gaps in financing for the agriculture, forestry, and land use sector. There's huge gaps in terms of capacity building, especially for developing and least developed countries. And then as well as gaps around data and some knowledge transfer for these types of things. And I just want to highlight a few things from the recent IPCC report that really underscore some of these points in terms of what's missing. Right, and so this is a figure that maybe some of you guys have seen before in terms of the sectoral emissions pathways to limit warming to 1.5 degrees. And we can see here that the first two curves are land use change and energy, right? That these things need to happen dramatically and simultaneously. But the first one is land use, right? We see net zero at 2030, right? This has to happen before all of the other transitions have to happen. And not only that, as I mentioned previously, like this action needs to happen in the next round of NDCs, right? We can't wait to stress the urgency of halting deforestation, of getting to net zero with land use change emissions in the next global stocktake. Like this is really the moment when this urgency has to be stressed, and we have to see this in the next round of NDCs. The next one is I think some really interesting work that the IPCC has done around synergies and trade-offs. And I pulled out some of the right, the nexus of kind of what we're talking about here today, right? When we're looking at the Sustainable Development Goal on creating affordable and clean energy, and then its interactions with land systems, right? The blue are synergies, so that's great. There's a lot of synergies there. But then the crosshatch shading with the orange are potential trade-offs. And so these are things that we really need to be aware of. We need to know that these exist, and they need to be managed really carefully in planning processes. This can't be something that we're developing energy systems and then later managing them. They need to be really proactively dealt with. And then finally, we know that there's not enough finance for anything, right? But something that really struck me when I looked at the sectoral flows of finance was around agriculture, forestry, and other land use. That the current finance flows are almost really not visible within this figure. That they're really minuscule compared to investment in other sectors. But not only that, the gray bar for where we need, that's a lot less than the other sectors, right? So we don't need a lot overall, but we need a lot more in terms of the multiplication of what we're already getting in terms of accelerating the transitions in agriculture, forestry, and other land use, right? The numbers here that the IPC estimates are from 10 to 31 times the current level of investment. So that was the IPCC, right? I'm gonna put on my hat for Conservation International for a couple minutes here and talk about some work that we've done, which is, I think, another really important complement to what the IPCC is putting out. Because that's at an extremely high level. But what I was talking about previously in terms of the global stocktake is that the outcomes and the information that we need, they need to be a little bit more specific than what we're getting from the IPCC. And this is where analysis done by organizations like ours can really help complement the information that the IPCC is putting out in terms of what countries need to be prioritizing and when they need to be prioritizing them, the action within their NDCs. And so CI and some of our partners have put together something called the Exponential Roadmap for Our Natural Climate Solutions. We launched this report at COP27. But I think we're still kind of understanding the implications of some of this analysis here. And so this, I think, is a really actually helpful interpretation of the IPCC curve that I put up previously here, because it's kind of hard to understand where that curve is coming from in terms of sources and sinks, and what it really means to reach net zero at 2030. And so you can see kind of where we are now in terms of the land sector as a net source. And so getting to 2030 into net, that doesn't mean that we're at zero, right? We're still talking about gigatons of emissions coming from the land sector, but we're also talking about the commensurate removals coming from the land sector. And then over time, slowly reducing the emissions and continuing to build that sink so that we're getting to the net sink by 2040, and then an even bigger one by 2050. And then we've mapped out a little bit about when and kind of the acceleration needs to happen in terms of nature-based solutions. And this is along the protection, sustainable management, and restoration of natural ecosystems. And I think one of the things that has really just stood out to me with this analysis is the importance of sustainable land management, of agriculture and grazing lands, and agroforestry, and those types of solutions, climate smart forestry. that is actually the linchpin of where the emissions reductions and the sequestration is going to be dependent on over the next several years. So the potential in terms of emissions reductions in sustainable land management is huge. But not only that, but the land shifts that we need for sustainable management for grazing lands and working lands, they also unlock the ability to protect and restore over time, right? The idea of reducing agricultural drivers of deforestation, of freeing up land for restoration. And so we actually calculate that about 80% of the emissions reductions and removals that are needed through the land sector are dependent on shifts within sustainable land management in some way. And so we can clearly say that for the next round of NDCs, that countries need to be focusing on this managed piece of nature-based solutions on sustainable land management. That protection and restoration are super important, but that the near-term action and the prioritization needs to happen within this management section. And you can see as well when we break it down geographically that the majority of regions have a huge potential in terms of that pink, right, the pink management section. But I want to end here on this idea, right, that we talk about land, and we talk about land and nature-based solutions a lot, but really the work that CI is doing and trying to bring in partners into this initiative as well is about people. People and enabling conditions. And I know that's something that our panelists are going to talk today about as well, the idea of the importance of multi-stakeholder action and bringing in the people who are working on the land and the people who help manage the land, and connecting them better and understanding the motivations and incentives that people need to create the changes that we need to see within both the land use and energy use transitions. So that's it for, I know I spoke for a while, but I just wanted, there's kind of a lot of context to put in here. And so I want to pass it over to our distinguished panel. We'll be starting with Giacomo Grassi, who will be joining us online. Giacomo is a scientific officer from the European Commission.
Hello.
Yep, great.
Hello, can you hear me?
Yes. Welcome, Giacomo.
Okay. I will try to share. Let me know if everything works well. Can you see that?
Yes, it's coming up. Yeah, we can see it now.
Okay.
I think, there we go.
Okay. Good morning to everybody. I'm Giacomo Grassi from the Joint Research Center from the European Commission. And I will talk today, after this nice introduction of the Global Stocktake, on some scientific findings on the role of land fluxes and some methodological issue on which it is worth paying attention. The outline of this presentation that I will start from the Paris Agreement Global Stocktake. I will describe a problem of a large gap on land use fluxes between models used by IPC and greenhouse gas inventories, the possible solution and a conclusion way forward. Since I cannot see well the screen, please interrupt me if there is any problem with the advancing of the slides.
Yeah, I think just one moment, Giacomo, actually, we're trying to make it so that we can see the full, some of your slides are a little cut off right now, so. Is that?
Like that works?
Not yet. Is that, are they? Yeah, Giacomo, they're asking if you can change the size of the slides, or maybe you can just go back to, yeah, that's, I think.
I mean, you want me just to show this?
Yeah, yeah. Oh, just a little bit lower. Maybe
lower?
Down another 2 clicks in terms of size. Okay, I think that should be good. Yes, go ahead.
Okay. So the context is the Paris Agreement, as you know well, the aim is for mitigation is holding global warming to well below 2 degrees. This requires reaching a balance between pathogenic emissions and removals. And again, please let me know if there is any problem with the slide. On the left graph, you see in black the trend of emissions from national greenhouse inventories. On the right, you see a range of emission scenarios, each associated with a range of temperature. To make the narrative a little bit more attractive, let's see the image on the right, where we put the Paris Agreement into a car. And there are 3 elements here. There are the policymakers represented by the driver. They hold the steering wheel and decide speed and direction. Then we have the car dashboard, which is represented by national greenhouse inventories that provide key information to policymakers and to assess compliance toward the Paris target. And then we have the navigation system that is represented by the IPCC models that provide possible routes for a specific destination. And once the destination is selected, in our case, the -2 degree, the policymaker may check the navigation system to see where they are. And a similar exercise is done by the Global Stocktake. So the collective climate progress is assessed by the Global Stocktake every 5 years, as you know, assesses the climate progress, collective progress, in the light of the best available science. The inputs essentially for this assessment are mainly the aggregated country greenhouse gas data on the one hand, and the IPC and other scientific data on the other hand. These 2 data will be compared, as shown in the graph, to compare the future gap. These will eventually, hopefully, stimulate increased climate ambition in the next round of the INDC. Why land use CO2 fluxes are so important? This graph, taken from the global carbon budget, shows on the left the emissions, the fluxes that are considered anthropogenic by the global carbon budget and the IPCC. Essentially, mostly fossil fuel emissions, but to some extent also land use change emissions are also very important. These land use change emissions are represented by a category of models called bookkeeping models. On the right, you see where these emissions go. Nearly half remain in the atmosphere. The other half, luckily for us, is taken up by oceans and by forest. The CO2 taken up by land, mostly forest, is simulated by a category of models called dynamic global vegetation models. Which is the problem then? The problem is that recent publications show that a large gap exists on land use fluxes, let's call it LULUCF, between what models, global model says, and what country greenhouse gas inventory says. And you see it in this figure on the left. So you have in blue and red, you have the models that are used in the IPCC assessment report for the historical period in blue and for future scenarios in red. And in gray and black, you see what country says in their national inventories and national communication, the unupdated reports submitted to UNFCCC. And you see that there is a huge gap. This gap, 6 gigatons of CO2, is even more than the whole emissions of US. This gap attracted attention by scientists, policymakers, and also media, and is confusing policymakers. Policymakers are asking, but is this gap a problem? Can we trust country LULUCF data? Why do we have this gap? And can we reconcile the difference? And in the following slide, I will try to address systematically each of these questions. First of all, is this gap a problem? Well, in short, yes, it is a problem. Because on the left, you have the ideal case where you have the country data in the past and projected in the future with NDC, and the scientific benchmark, which is the scientific scenarios needed to be compatible with the Paris Agreement. And then this future gap is estimated. If you have, like we have in the right, a gap in the historical period, then the future gap will not be estimated accurately. And if not addressed, this gap in the historical period, counter progress may look better than it is. Essentially, the global stocktake requires comparability, apple-to-apple comparison, because what we have now is essentially, in short, an apple-to-orange comparison that may hamper an accurate assessment of the collective progress. So second question, can we trust country LULUCF data? Well, we recently published the most complete and disaggregated collection of country LULUCF data officially submitted to UNFCCC through National Greenhouse Gas Inventory, National Communication, Biannual Update Report. We also took into account RED plus emissions when were relevant. And the outcome of this analysis, the quality and quantity of country LULUCF data improved, but significant gaps still remain, mainly from developing countries. Overall, countries report a relevant global LULUCF net sinks, mostly due to forest. And this data, which is publicly available, disaggregate the country LULUCF data into 4 categories, which are forest land, deforestation, organic soil, and other. And this disaggregation is somehow a minimum common denominator between what country reports with a different level of aggregation, what models report. Third question is, why do we have this gap? Well, essentially, it's mostly due to different system boundaries, different definitions of anthropogenic forest sink. This figure is pretty complex, but in short, above you have how the global models, the bookkeeping models and these global dynamic vegetation model capture what they consider anthropogenic fluxes and what they consider natural fluxes. And below, how countries following the FPC guidance on National Greenhouse Inventory, how they capture the anthropogenic fluxes. Essentially, countries report as anthropogenic all fluxes that occur on land that they consider managed. And as you can see, the boundary of the area of what is managed land and of the processes included differ between models and countries. These two approaches were developed years ago for different scopes. Both are valid in their context, but are not comparable. So no one approach is better than the other, but the only mistake we can do is compare one with the other. It would be an apple to orange comparison. So summarizing the problem with the help of the analogy of the car, the gap in land use fluxes by global models and national inventories is like if the navigation system uses miles and the dashboard kilometers. We cannot say that one metric is more accurate than the other, but this mismatch may seriously confuse the driver. So the easiest solution that we proposed is translating the navigation system in a way that the driver doesn't get confused. Can we reconcile the difference? Well, yes, a lot of work has to be still to be done, but we proposed a pragmatic fix to reconcile this difference. And essentially, you see on the figure on the left, which is the figure I showed before, and you see the different system boundaries are essentially the model consider LULUCF only the fluxes mostly due to land use changes, so the orange box. By contrast, country consider not only the land use change fluxes, but consider also part of the sink that model consider natural, countries consider it anthropogenic. So it's mostly not a genuine disagreement on the absolute level of fluxes, but on the labeling of these fluxes, to what extent they can be called anthropogenic and to what extent they can be called natural. So through aggregation of results from global models, essentially we estimated the amount of emissions that models call anthropogenic and call natural and country call anthropogenic. And we reaggregated essentially estimates. At the global level, this reaggregation works quite well, work very well. You see the figure on top left. You see the regional estimates that you can find even in the APC. LULUCF in the APC is shown to be a quite significant source, a source of nearly 5 gigatons of emissions, while country, the blue bar, indicates a quite significant sink of -2. And through our methods, we are able to reconcile the model's results in a way that at global level, the match is much improved. And this match improves also when we disaggregate at the level of developing countries, and also for main reasons. And the approach that we use, I'm not entering the details here, represents a blueprint for comparing anthropogenic land use fluxes at various levels. On the left, you see again the original, the before reconciliation, the original values from the bookkeeping models. There is the value that is used of feature for the AR6 and what countries report in their inventory. So you see a big gap between the orange and the blue line. Below is after reconciliation. The models have a strong interannual variability because they capture more than inventory the interannual climate impact on the fluxes. These approaches not only allow to reconcile the magnitude of fluxes, but also identify areas for further investigation. Because for example, we still have for individual countries, but also for regional scale, we still have some differences between what model says and what country says. This issue is now well acknowledged in the global carbon budgets, in the IPCC summary for policymaker of the synthesis report. So the summary of the IPCC AR6 cycle includes a footnote that describes the problem, describes the gap that I showed before, the fact that global data set make different choices about which emissions removal on land are considered anthropogenic. And also conclude that using emission estimates based on inventory, the remaining carbon budget that are mentioned in the IPCC summary for policymaker and the synthesis report must be correspondingly reduced. This issue is taken up also in the synthesis report from the Global Stocktake, the initial synthesis report published in March last year, where essentially is written that adjustment should be made when country data on LULUCF are compared to LULUCF data from IPCC and scenarios for the future. Essentially, it follows what we advise in our studies. In conclusion, there is a worrying large gap in LULUCF estimates between countries and global models. This gap has to be taken into account in the Global Stocktake because otherwise would jeopardize the assessment of collective progress. This is essentially due to different definitions of anthropogenic forest and can be largely reconciled with a crude approach, but at least it helps. Other differences exist and a lot of work still to be done. From the countryside, what is needed is increased transparency and completeness of estimates, especially from developing countries. I fully understand that developing countries are starting now, many developing countries, to address the challenges, the huge challenges of reporting fluxes from different land use changes. And a major step forward is expected to occur in end of next year, where under the enhanced transparency framework reporting. And what I want to point out here, it is absolutely important that in the future effort by countries, better definitions and even area of managed land are made available in the country report. So the first step when producing estimates for land use according to APC guidance is define the area of managed land, which is the area on which fluxes have to be reported following the APC method. And also more clarity on LULUCF within the climate target would be needed. From a global modeling point of view, what next steps would involve a better representation of land management and land use dynamics, and the result is disaggregated in a way that makes them more comparable to countries, like I showed in the previous slides. In conclusion, reconciling land fluxes from countries and models is a key step for increasing, not only for assessing collective progress under the Paris Agreement, but also for increasing confidence in land use fluxes at country level and attracting mitigation finance on land use. Without confidence, there is no investment in land use mitigation. As a very conclusion, as you know, if you don't measure, but also if you don't trust your measure, you don't manage. What we need is more comparable estimates so that we can truly compare apple to apple, and based on that, made additional steps for enhancing mitigation in the subsequent round of INDC. Thank you.
Thank you so much, Giacomo. Great. So moving forward, we're going to switch topics just a little bit, and I am pleased to introduce Ms. Amy Fraenkel, who is the Executive Secretary for the Convention on the Conservation of Migratory Species.
Thank you very much. Well, so you might be wondering, what does the conservation of migratory species of wild animals have to do with climate change? And it turns out quite a lot. So let me just give you a few quick thoughts. The first is that migratory species are an integral part of the ecosystems in which they're found. We did some work with this, we're doing work with the saiga antelope, which is in the Central Asia steppe. And at one point, there was a crisis due to a number of factors, and saiga population decreased phenomenally down to only like 50,000 animals from several million. And it completely changed the landscape. It turned out that their being in that landscape and their grazing patterns were extremely important for the diversity of plants and the maintenance of other ecosystem features, the water that was provided for millions of birds that stepped through. And when the population recovered, so did the landscape. So we know that many migratory species are essential for those landscapes. They also provide numerous key functions and ecosystem services, such as birds and bats are pollinators. Many of the birds and bats are pollinators. Vultures provide pest control, and many land animals help sequester carbon and provide seed dispersal. In addition, of course, migratory species are not just found in one place. They rely on a network of specialized sites for breeding, feeding, and resting. We know that climate change is having a significant impact on migratory species, and we're actually working on the first ever study on that topic, which will be released at our COP, which is coming up in October this year. This takes several forms. First, the habitats on which migratory species rely are changing, sometimes very rapidly. And because migratory species rely not only on one area, but on a network of sites during their life cycles, they may be especially vulnerable to climate change if any one of those habitats on which they rely is compromised. Climate change also affects the phenomenon of migration itself. For example, species might migrate earlier and arrive at a key stopover site only to find that the key prey that they expect to find there are not there. It's a question of timing, or it's called phenology. So it's a mismatch of centuries of evolutionary precision. Third, one of the greatest impacts on migratory species is also a major factor for climate change, the topic today, which is the destruction of habitat. Thus, by addressing the destruction of habitat and land use change, we will be benefiting both. Now, migratory species exemplify one of the most essential concepts for biodiversity and climate change, which is ecological connectivity. At its core, this concept simply recognizes that islands of biodiversity are not functional, not for migratory species, not for climate change, and not for people. We're very happy and we are very involved in the negotiations on the Kunming-Montreal Global Biodiversity Framework. And as you probably know, one of the key targets calls for 30% of land area and 30% of oceans to be part of area-based protection measures. But an approach that's only focused on officially, legally, protected areas is not sufficient to protect migratory species or for the functionality of areas. So this is why it is so important that Target 3 recognizes that area-based measures need to prioritize the protection of sites that contribute to ecological connectivity. So it's where you protect matters. And if we protect those sites that are important for migratory species, we actually leverage conservation that's needed for habitat and for climate change. Now, turning to climate mitigation, of course, a key part of the solution is a rapid shift to renewable energy. But we need to do this in a way that also doesn't jeopardize migratory species and other aspects of biodiversity. So this brings me to an incredible initiative that started with the Convention on Migratory Species and has grown and now really is ready to take off to reach all countries and partners that are committed to renewable energy as part of the climate solution. Back in 2016, the CMS Conference of the Parties established the Energy Task Force, the ETF, and it is a multi-stakeholder platform bringing together governments, investors, scientists, the private sector, civil society, and many of the global and regional financial institutions, including the World Bank, the IFC, the ABD, the EBRD, and many others. It has really become a vital platform, and its premise is very simple, which is how can we help countries that want to move to renewable energy do so in a way that minimizes impacts on migratory species, starting with wind and looking at the impacts on birds and bats. We're also looking at offshore and starting to look at that now. So what we do is first, bringing the stakeholders together is part of a key part of the process, and as you can see, it's an incredibly diverse set of actors. But what we found is that, there's evidence that the timely consideration of impacts on migratory species and biodiversity actually has proven economic benefits because it avoids costly and inefficient projects, it increases local ownership and acceptance of investments of new infrastructure, it reduces the need for mitigation, restoration, compensation if there's challenges to the sites, and it also boosts enhancement of biodiversity at the local level. So the ETF has facilitated key solutions, technical and best practices such as spatial mapping tools that can assess the potential risks and then provide guidance to governments. How do you do this? How do you meet your commitments under the Paris Agreement and minimize the impacts on biodiversity? Some examples include, and you might hear about some of this later, BirdLife, which is a key partner for us. They have a new avian sensitivity map called AviStep. There's also a soaring bird sensitivity mapping tool, which provides assessments for over 90 species in relation to onshore wind development in the Mediterranean, the Middle East, and North Africa. So what we want to do now is develop this further so that we have data for all countries that basically can look at what's the best siting for wind and where are the migrations happening and how can we make sure they're avoided in addition to operational measures. Another example, the IFC, actually, one of the partners I mentioned, has just released or rolled out best practices for post-construction monitoring so that you see what the impacts are and have a data loop going back to it. So in conclusion, on this point, with renewables set to increase so rapidly, we need to make sure that as we go forward that we also scale up the solutions to minimize impacts on migratory species. The last thing I want to say is, I've been, as you see by my small, summary of my resume, I've been at this for a while. I've worked on the climate side, I've worked on the biodiversity side, and to me, this struggle to try to come up with words that say, biodiversity is relevant for climate change is really so strange to me. I mean, it's one planet. The fact is we've created these different silos for how we negotiate the solutions, and it's evolved at different times. But I feel like we're struggling almost too hard to come up with the little catchphrases like nature-based solutions. It should be obvious that if we protect biodiversity, we're going to help climate change, and if we reduce climate change, we'll help biodiversity. Just one quick anecdote. I remember when I first came to the Convention on Biodiversity, there was an anniversary of the UN RED program. It was actually in New York at the zoo there. And I saw that the climate change people all saw biodiversity as being helpful for the climate objectives. And the biodiversity people saw UN RED as, climate change leveraging help to protect biodiversity. It was like this strange, like through the looking glass phenomenon. And I really think we can get beyond that and need to elevate the common sense approaches, some of which I've quickly highlighted today, to show how these approaches need to work in tandem. Thank you very much.
Thank you so much, Amy. And I understand that we have a quick video to demonstrate a little bit more about the Energy Task Force.
The global energy demand is expected to rise 30% by 2040. Meeting this target while fighting climate change means an increase in renewable energy. However, transitioning to renewable sources of energy, such as wind and solar, could negatively impact migratory species and their habitat. As an example, more than 300,000 birds could be killed annually in Canada and the US by ill-planned wind turbines. Migratory species are an integral part of nature and provide important functions such as pest control, pollination, and seed dispersal, and generate millions of dollars and jobs from a variety of sectors. Over 11 million hectares of natural land and more than 1,500 threatened species could be impacted by renewable energy infrastructure development. CMS, the Convention on the Conservation of Migratory Species of Wild Animals, is an environmental treaty of the United Nations that established the Energy Task Force in 2015 to reconcile renewable energy and wildlife conservation. The CMS Energy Task Force is a platform where governments, multilateral environmental agreements, investors, researchers, and NGOs come together to share information, establish best practices, and promote innovative and responsible solutions. It is possible to achieve the goals of the Paris Climate Change Agreement while protecting migratory species and their vital ecosystem services. Together, clean energy and thriving migratory species mean a healthier future for people and nature. Learn more about the CMS Energy Task Force and how to join it by visiting our website.
Awesome. Thank you so much for sharing, Amy. And next, I'd like to introduce Ms. Araceli de Carlos Sebastián, who's the Senior Climate Change Analyst from Iberdrola, who is going to give us a private sector perspective on some of these initiatives. Welcome.
Hi, good morning all. Hi, first I would like to thank you for having me here. It's a pleasure to be here representing Iberdrola and to bring in the views of the private sector on such an important matter. Being a global energy company, utility, I would like to share with you 5 key messages. The first one is that, well, as has been said in this panel, we are facing multiple crises, and these are not only environmental, of course, climate change, biodiversity, but they're also socioeconomic with energy crisis, inflation, geopolitical tensions, etc. And all these crises are interlinked and have in common our high dependence on fossil fuels. The good news is that they also share a solution, which is a transition to an energy system based on renewables, which are now fully competitive against fossil fuel alternatives. My second message is that this transition is good for the environment, it's good for the planet, it's good for people, and it's good for the economy. And It is obvious, and as has been said here in this panel, that this is essential to address the interlinked crises of climate change and biodiversity, as well as others, such as air pollution, water exploitation, etc. But it's also important to bear in mind that renewable transition is also good for socioeconomic development and prosperity, as it can provide competitive, secure and safe and clean energy for all, while also being a catalyst of job creation and industrialization. And this needs to be important, that benefits are provided to local communities. And my third message, which links very well with what Amy was saying, is that this transition can be done in a way that it's compatible with nature preservation and restoration. When we assess the environmental impacts across the full life cycle of energy solutions, it is clear that fossil fuels have a much more damaging environmental impact than renewables. However, most of these impacts are not perceived by final consumers. We don't see the fuels being transported overseas, the extraction, or the indirect effects of climate change. However, renewables being more widespread and have low, of course they have impacts, and these are more local and visible. And we need to be aware of this, because this is creating some social acceptance problems as well. However, and as Amy was saying, we have increased tools and solutions available to ensure that this renewable deployment is properly located and managed. And here we really appreciate all the efforts that is being done in terms of developing safe seating tools and everything. And we have all these tools to ensure that we can provide enhanced and long-term benefits for both biodiversity and people. And the key is we need to accelerate the transition, and the key is that these benefits are maximized and provide long-term benefits and recognized for as well by local communities. And this is also important for both for biodiversity conservation and for addressing climate change. My fourth message is that as Iberdrola, we're a company, we are firmly committed to delivering positive benefits to nature and people through our renewable energy deployment. So this commitment has been present, has been always present in our development, but we want to go further. And for this reason, we have launched a pioneering and ambitious program called the Convive program, which aims to be a platform to compile and launch numerous initiatives to multiply the benefits that renewables can provide for to nature and people. Convive is a Spanish name, but it refers to coexistence of renewables in harmony with nature and people. And it's structured in three lines of action, which I will briefly describe, and I can give you more detail if you want later in the Q&A session. The first line of action is protecting and improving biodiversity. We have approved a very ambitious biodiversity plan with objective to have a net positive impact on biodiversity by 2030. And this plan is based on applying the conservation hierarchy with many measures, over 1,600 measures already taken in last year, not only to minimize our impact on biodiversity, we want to go further, we want to improve biodiversity to a better state. And the thing is that renewables offer many opportunities when developed on previously degraded or agricultural lands or industrial lands, and we have a lot of opportunity to restore and rehabilitate ecosystems there, and also to reconcile renewables offer the possibility to reconcile many uses on the same place. So we are working on delivering those positive outcomes and trying to restore habitats, reintroduce species that were previously not there, and doing many actions in that regard. The second line of action is we need to ensure that these benefits reach local communities, and local communities are engaged not only in accepting renewables, but also in biodiversity conservation, which go hand in hand. And this is done through local employment promotion, promoting local suppliers, local industrial development, direct benefits to communities, and also trying to find ways to reconcile economic activities with renewable deployment, such as, for instance, agrovoltaics or that promote synergies between food and energy and biodiversity protection. And our final line of action is collaboration. We, with others and alliances, to have a multiplier and tractor effect. And here I have the pleasure, and this is quite bad news, to announce that today we are announcing a 3-year strategic alliance with our colleagues from BirdLife International to work together on accelerating this transition, which is positive for both nature and climate. It's an alliance to join forces, to work together, to learn from each other, and to find innovative ways to provide enhanced and long-term benefits for biodiversity. So we are looking forward to this collaboration. And we're also part of other coalitions and work that is being done, like the Offshore Coalition for Nature and Energy, or the Clean Action Coalition, linking nature and energy climate action, and many more. And of course, we really appreciate work that's being done on the Energy Task Force. And we think that these alliances are crucial to advancing nature-positive energy systems. My final message goes saying, like, we've arrived this far and we are making progress, but this progress is not enough. We really need to accelerate the transition urgently and at scale. So what do we need? And here I identify 2 key elements. The first one is we need a coherent set of policies. Here, voluntary approaches are not sufficient. We need a coherent regulatory approach that integrates fiscal measures, incentives, just transition policies, regulation standards, and that provides a level playing field for all, legal certainty, and attracts investments into this area. So this is crucial. And the second thing, which is, I don't know if it's more important, it's alliances. I already said it before, but I emphasize it. We cannot do this alone. The challenge is too big. And we need to come together, governments, civil society, companies, and we need to listen more to each other, to reconcile diverse interests and move together in the same direction. I think companies, we need to improve the way we do things, and we are working on that. But governments need to facilitate this transition and be equipped to accelerate it and provide the tools to do it. And the civil society, scientists, NGOs, and you need to explain to society the importance of this and help us in this journey. No? And that's why I think workshops such as this one, where we bring different views, are so important. Thank you very much.
Thank you so much, Araceli. So next, and our last panelist here, I'd like to introduce Ms. Carla Freund, Policy Officer for Nature-Friendly Energy Transition in Europe with NABU.
Are you gonna? Oh, great. Yeah, thank you to all the panelists before me. I will try to keep it brief because I think we're running a bit behind and we still want to maybe have some time for questions. So just really briefly about NABU, because I don't think everyone knows my organization. We're the oldest and largest membership-based environmental organization in Germany, spanning we have about 900,000 active members across Germany, and we're also part of the BirdLife network, which we've heard before, which is a partnership-based organization with around 115 members across the globe. So to jump in really quickly to the topic at hand, we're talking about the development of renewables and I'm risking sounding a bit like a broken record because my previous panelists have also hinted at some of the points that I'm going to make here today, but we need a fast, deep, and basically immediate energy transition. But this doesn't come without its own problems. So as you can see on the image behind me, the footprint, so the sort of space footprint of renewables is quite a bit higher than that of fossil fuels. But this, of course, isn't a reason to not develop renewables altogether. We need, just to highlight the sort of how much more renewables we need. We already have around 65 million meters of grids, and we'll need to increase that dramatically. And we also will need to quadruple the amount of renewables that we already have, which basically amounts to building the world's largest solar farm per day until 2050. So as you can see, that's a really momentous task, and one that won't come without its own problems. But of course, we also have solutions. Wind and solar primarily are widespread resources. So we have a lot of opportunity to identify areas that have low ecological value, which was already mentioned before, such as agriculture and industrial sites, and prioritize those areas of low sensitivity. And at the same time, if you identify these areas of low ecological value, there's also potential for restoration as well, because it won't be enough to just protect the environment that we have. We also need to restore. And yeah, so from a BirdLife perspective, this has to do a lot with sensitivity mapping, and I'll go into that a little bit more in detail later, because I don't think everyone's familiar with this. So what do we have to lose? Could you change the next slide? So what do we have to lose if we don't properly site renewables? So we could jeopardize around 100 million hectares of natural lands globally, including over 3 million hectares of key biodiversity areas. And that ranges around 1,500 globally threatened species. And this loss of natural habitat could release around 400 million tons of stored carbon, and that would also undermine our climate targets. So this obviously shows the interlinkage between the two, biodiversity crisis and climate crisis. So already on the next slide. And I don't know why the last image is missing, which is kind of the key point here. There we go. Okay, that makes more sense then. So obviously, I've already hinted at sensitivity mapping and the importance of it, but there's more to just identifying sort of avian sensitive areas. We need to identify where are wind resources. So this example obviously goes into wind development, geology, where are the areas that we can even build wind, and the grid network, which underpins our entire energy transition, because without a grid, we won't be able to access the clean energy that we've developed. But we still need to take into account sensitive areas and use the mitigation hierarchy to primarily avoid these areas, so that we can have an energy transition that benefits biodiversity and nature. So now my next slide will be looking at sort of the case study of how NABU would see a nature-friendly energy transition for the sea. We've focused a lot on offshore wind in the last years, because it is an area that is expanding rapidly in Europe and also across the globe. And the EU has recently set really high targets, with increasing to 300 gigawatts of offshore wind in the European sea space. But we also have to recognize that there is already massive disturbance within marine protected areas. Our marine area is not in a good state and is also not recovering. So this is a situation that we need to face. And offshore wind does require a lot of space. And anthropogenic pressures are rising. So, I mean, the wind sector is sort of the final sector that's entering the ocean space. The issues that we have in our ocean are not the result of the development of offshore wind, but the cumulative impacts could be something that really is the sort of final straw in the functioning of the ecosystem. So theoretically, the marine space should be planned based on an ecosystem-based approach. However, there's been several evaluations done on EU marine plans, and that's identified that most of them are not using an ecosystem-based approach. On the top right corner, you can see the EEZ of Germany, and you can see how full it already is, with red being areas designated for offshore wind, blue being shipping routes, gray areas being sand and gravel extraction, and the green areas being MPAs. So NABU commissioned what we refer to as a traffic light study, which is similar to sensitivity mapping, where we've identified green areas which would be most suitable from a conservation perspective for the development of offshore wind. Then yellow areas where offshore wind can be constructed with restriction and focusing on mitigation measures. And then red areas being highly sensitive areas that should be avoided from a conservation perspective. So we've done this for the construction phase and the operation phase of offshore wind because those two have different impacts. And on the next slide, I'll show you the actual maps. So on the left, you can see the construction phase. This study focused on 14 different bird species, harbor porpoises, and 5 different biotopes. So on the left, you can see during the construction phase, and on the right, you can see operational phase. And I know developers always get a bit nervous when they see all the red on the map, but I also want to highlight that this is a tool that is meant to guide decision-making on where to build offshore wind and not make decisions on where to build offshore wind. So you can see that there are some sites that are in red areas, and we've been working together with the authorities in Germany to discuss with them on how to potentially move these sites into more green areas. And the study has also identified that the green areas are enough to actually reach the target of 70 gigawatts in the German EEZ, which is the target set by Germany. And so the issue here is that, so the Marine Spatial Plan is already set, and the timing is a little bit off. I mean, the study was published after the development of the Marine Spatial Plan, and obviously the sea space is not empty. So a lot of the green areas are shipping routes, international shipping routes. So this also highlights the fact that there needs to be regional and sort of cross-governmental cooperation between countries, because we'd have to cooperate, for example, with Denmark, which I think where the shipping route originates, to be able to maybe move the shipping route to accommodate more offshore wind. So it requires a reprioritization of our sea space to accommodate enough offshore wind to be able to meet our climate targets and avoid sensitive areas. So I'll stop there so that we can move on there.
Thank you so much, Carla. So we're just about at time here. I just want to highlight, just kind of bring it together, just a couple things really quickly here. So we've heard a lot. We've heard about the land transitions that were needed. We've heard about the renewable energy and managing synergies and trade-offs. And so thinking about what does this mean for the global stocktake, right? So I think one of the biggest things that we want to see in terms of the highlights in the global stocktake is this idea of that countries need to align their Paris Agreement strategies with their strategies for biodiversity protection, or national biodiversity and strategies and action plans, right? And explicitly calling for that within the global stocktake. One additional thing is that we see a lot in outcomes calling for safeguards, right? But a lot of times it's sectoral based, and so this idea of explicitly calling for biodiversity safeguards when we're talking about renewable energy transitions is something that we really want to see. And then, talking about the importance of recognizing the role of traditional knowledge in local communities is very important in this as well, and in the people who are on the land and using it. One additional thing is on finance, scaling up finance. An important element of this is redirecting finance that's currently going towards subsidies and harmful activities on land, and redirecting that finance into these, the positive incentives and positive actions that we need for climate action. For climate resilient food systems, biodiversity positive renewable energy transition. And then, as my colleagues also mentioned, right, and a really important element of this is coherent policy frameworks and aligned budgets, both for governments, but then especially for the private sector, and providing businesses with the regulatory certainty that they need to take action. And then, as our Giacomo and some others mentioned, right, this idea of making sure that we have the right information and the right data to make clear decisions is really important. And the global stocktake can galvanize action that's needed within the UNFCCC and IPCC to help harmonize some of the data and accounting frameworks that we need, and that countries need to make better decisions within their NDCs. And then finally, I think a message that we want to make sure that is very highlighted within the stocktake is the importance of collaboration and this idea of it's not only about NDCs but enhancing international collaboration. And I think that the examples that we have here today are really important in terms of creating partnerships and multi-stakeholder action. So we're at time here. I think that we potentially can stay a little bit longer if there's a couple questions. Also happy to stay here and answer questions from folks. I see here and here. Karen, if you want.
Right, thanks. Can you hear me okay?
Yeah, go ahead.
So my name is just a point of information, hopefully a resource that could be quite useful for nature safe energy. I'm Dean Cooper. I'm the Global Energy Lead for WWF. Looking at all the different perspectives and the different stakeholder groups. BirdLife, representing CMS, is part of Clean Action. Iberdrola is a member of Clean Action. So trying to bring all of this together. If you just Google Nature Safe Energy WWF, then you'll see the reports, and that could be quite useful, I think, for everybody here. So thanks for that.
Thank you. And we'll just take. Do you have a question?
Yes.
Yeah, great.
Just a quick question. I'm Rebecca Humphries. I'm head of European climate policy at the Nature Conservancy. I'm just interested in your thoughts on the discussions on this global renewable energy target that are currently ongoing. And this will send a massive signal to expand renewables. And so I was wondering how can we ensure that the importance of adequately citing those renewables is included in those discussions, while not undermining the importance of the energy transition as Dean just mentioned. Thank you.
Sorry. Yeah, I think it's an excellent question, and I think, overall, we're definitely supportive of a renewables target. We need to get to 100% renewables as fast as we possibly can. I think maybe a good thing to be is not be naive about the fact that there are impacts, and we want a long-term sustainable energy transition, and that will involve it being beneficial for biodiversity and for climate, and so. I 100% agree with the speaker from WWF before. It's the impacts are not even remotely the same, but I think we shouldn't make the mistakes that we made in the past about being naive about the impacts that are at hand. I mean, I know it doesn't really answer your question how we can ensure that in the negotiations. Maybe someone else has a better answer there, but yeah, that would be my input.
I just wanted to add that if you look in the biodiversity, what the targets that were just adopted in Montreal, the first target is on spatial planning. And, it sounds not very sexy, it's boring, spatial planning, but it's essential. And, it's for biodiversity and for climate. So the commitment's already there. And I think we just need to make sure, connect the dots for the policymakers that are at the different tables. One other point is that we've also been working with IPBES, which is also based here, and they're actually scoping right now for consideration at the plenary, the next plenary they have in July, I think it is, here in Bonn, a study on spatial planning or an assessment on spatial planning and ecological connectivity. So these topics are very, very current, and we just need to make sure that they're taken up in the policy discussion. Thanks.
Of course, we are supportive of renewable energy targets, and I just wanted to emphasize that the sector is also supportive of, and as a colleague of WWF was saying, of having the tools to ensure that we are doing this properly. And we welcome all these safe-setting tools, and I think it's good if governments plan around this. And because for us, it gives us certainty on where to invest, it prevents problems and enables more efficient permitting procedures if administration already knows what to do. So I think it's positive for everyone. So.
Yeah, just one last thing. I think bringing it back to the global stocktake and this idea of moving forward in action, and I can't stress enough what Amy mentioned on the importance of spatial planning, but the idea that countries still need capacity and information and data to do those things effectively, and through the implementation of the Paris Agreement, the Enhanced Transparency Framework, the UNFCCC itself and the mechanisms itself can be a springboard and for helping, level the playing field and make sure that all countries have the tools to be able to manage the land and coastal transitions that we need and manage the synergies and trade-offs in an efficient and coherent way. And so I think that's an important piece, right? This idea of having that partnership, but then the idea that the stocktake itself can call attention to the importance of the need for all countries to have access to these tools and to rapidly develop the capacity and the tools to manage these transitions effectively and finance them as well. So we are past time, and thank you to the IT folks for staying and allowing us to be in the room a little bit longer. Happy to hang around outside the room for a little bit if there's any more questions. And thank you so much for all of your time and attention today.
Thank you. Bye.